Today's topic is connection management. The transport layer uses two types of protocols, TCP and UDP. TCP, Transport Control Protocol, used in reliable data transfer. That is, the data is received in sequence and without any loss. And it is also provides a service of connection oriented. The connection oriented means it establishes a dedicated connection between users before data is exchanged. It needs some form of resource reservation called bandwidth. After data transfer takes place, connection is cleared or broken. For example, telephone network. Next, UDP. UDP, Datagram User Datagram Protocol. It is used in unreliable data transfer, and the connection is connectionless service communication. The service is connectionless, which means no connection is required. Information is transferred using independent data units. Each data unit contains complete destination address, that is where to go. For example, postal system. And here the packet sequence may also get lost or delayed. That is, it doesn't receive the acknowledgement properly. Unlike UDP, TDP is a connection-oriented protocol. That is, the process can run on any type of machine in the internet. In other words, the connection has to establish before we can start sending data. During this connection establishment, both sides can exchange data. For example, they can negotiate what is the maximum segment size that they want to use, and also exchange initial sequence number, and also figure out the acknowledgement type. Apart from this, we can also allocate resources, that is buffer space. For example, once the connection established, both sides, the sender and receiver, are going to allocate some buffer space for the send buffer and also for the receiver buffer. Next, we will see how much is actually allocated is a function of operation system. Let us look at how connection is established in a next slide. In the next slide, you are using is connection establishment. Here, the problem with the simple connection request and communication accepted exchange is that the network can lose, store, and duplicate packets. This behavior causes serious problems. To overcome this problem, you are going for delayed duplicates. The various ways to attack the problem are using a throwaway transport address, give each connection a connection identifier, or a mechanism to kill off aged packets, restricted subnet design, or hop counters, or timing stamping. Here, the primitives. Here you are seeing the three types of connection by using three-way handshaking. First figure indicates a normal operation where the host 1 is sending the connection request with sequence number X to the host 2. When host 2 receives the connection request from the host 1, it sends the acknowledgement to the host 1 with a sequence Y, and along with the sequence Y, it also sends the acknowledgement of X. After receiving the acknowledgement along with the sequence number, host 1 again sends the data to the host 2 with a new sequence and acknowledgement with Y. This is called three-way handshaking. Next figure shows the old connection request appearing out of nowhere. Here, host 1 already sent the connection request to the host 2, but the old duplicate connection request is received by the host 2 with a sequence X. This host 2 again sends the acknowledgement with the sequence Y along with the acknowledgement of sequence X. But host 1 knows that it doesn't send the sequence request to the host 2 now. That's why it rejects the acknowledgement of Y. Similarly, in connection figure, she shows the duplicate connection request and the duplicate acknowledgement. In this also, host 1 already sent the connection request to the host 2. Here, host 2 is receiving some duplicate connection request which is lost previously. This duplicate connection request or the old connection request is occurred because of the because of the because of the because of the connection from one host to the another host may be of many ways. The receiving of the data from different way may take different time. Because of the delay, there may be an occurrence of old connection request and a duplicate connection request. Next figure, in figure C, the other intermediate duplicate connection request is received by the host 2. Then that sends the acknowledgement with the new sequence and the acknowledgement X. Then host 1 knows that it doesn't send any connection request and any data to the host 2. That's why it rejects the acknowledgement. In this figure shows the asymmetric release. Here you are having two types of connections. Connections of transport can be released in two ways, asymmetric and symmetric. If one of host terminates connection, then in both the direction, data communication will be transmitted is called asynchronous connection. In synchronous connection, if one of the host disconnects connection, then it cannot send the data, but it can receive it. This is the example of asymmetric release. Here, after the connection is established, host 1 sends a transport protocol data unit that arrives properly at host 2. Then host 1 sends another transport protocol data unit. Here, host 2 issues and disconnect before the second data arrives. This result is that the connection is released and the data is lost. The other type of connection release is synchronous connection release. The more significant release protocol is needed to avoid data loss is to use asymmetric release, in which one direction is released independently to the other one. Here, a host can continue to receive data even after it has send and disconnect data. That is transport protocol data unit. Asymmetric release does the job when each process has a fixed amount of data to send and clearly known when it has sent it. Once one can wait a protocol in which host 1 says, I am done. Are you done too? If host 2 responds, I am done too, goodbye, the connection can be safely released. It is here, it is in this figure, it is also called as four-way handshaking of connection terminal. The figure indicates the four protocol scenario for releasing a connection. In first case, it is a normal case of three-way handshaking, and the next is final acknowledgement lost. The connection release, in first example, the host 1 is sending the data release to the host 2 with an start timer. Then after receiving the data release from the host 1 to the host 2, then host 2 again sends the data release with the timer to the host 1. After receiving the data release from the host 2, host 1 releases the connection and releases the connection. After releasing the connection, it sends the acknowledgement to the host 2. Whereas in second figure, the host 1 sends the data release to the host 2 with a start timer. After receiving the data release from the host 1, host 2 also sends the release with a start timer. Then host 1 releases the connection. After that, host 1 sends the acknowledgement to the host 2. But the acknowledgement is lost and host 2 doesn't receive the acknowledgement. At that time, host 2 will wait up to the timeout of the start timer. After the timeout, it releases the connection. Here, disconnecting the connection between two users. After sending the data, we want to release the connection by host 1 or by host 2. The next figure shows the response lost, and D figure shows the response lost and subsequent data release loss. In this, so host 1 sends the data release to the host 2, but the host 2 sent the data release is not received by the host 1. Here the data release of host 2 is lost in intermediate. At that time, host 1 will wait up to the timeout. After the timeout of the host 1, it again sends that it understands that the host 2 doesn't receives the data release which is sent by the host 1. That's why again it sends a data request to the host 2. After receiving the data request from the host 1, again host 2 sends a data request to the host 1. After receiving the data release from the host 2, it releases the connection. After releasing the connection in the host 1, it sends an acknowledgement to the host 2. After receiving the acknowledgement from the host 1, host 2 is also releases the connection. In next figure, host 1 is sending the data request, data release to the host 2. Host 2 sending the data request to the host 1, but it is lost in intermediate. That's why it waits for a timeout and again it sends the data request. Again, the data request which is sending by the host 1 is lost. Then host 2 doesn't receive the data request from the host 1. That's why it waits up to some timeout and after that it releases the connection. Similarly, at the host 2 also it waits the timeout of the for n rotations in timeouts and then releases the connection. The next
transport service primitives. This is a state diagram for a simple connection management scheme. In this, the solid line shows the client state sequence and the dashed line shows the server state sequence. Here, the italic are caused by packet arrivals. In this, the first is the ideal state. In this, if the receiver is in ideal state, it requests for the connection. In this, you are having two types of connection. One is GPDU receive, another one is connect primitive executed. The connect primitive executed is across client side, which established active pending establishment, whereas in server side, the connection request data receives using passive establishment pending. Before the establishment of the connection, it is connected primitive executed across the server and across the client. It is connection accepted data received. After the establishment of the connection, it has to disconnect the connection. Further, it sends disconnection request data received to the passive disconnect pending across the server and across the client. It sends disconnect primitive executed to the active disconnect pending. After that, the disconnect primitive will be executed across the server and disconnect request data received across the client. After that, the two hosts will be ideal